बिस्मिल्लाहिर्रहमानिर्रहीम। इक़रा बिस्मि रब्बिकल्लज़ी खलक़। Assalamu alaikum students. I am Hamadur Rahman from DPS Lahore. It's our lecture number 13 of class 9 chemistry. Students, today we are going to start chapter number 2, in which we will discuss theories and experiments related to atomic structure, electronic configuration of atom, isotopes. Now, topics of our today lecture. Students, in our today lecture we will discuss cathode rays and discovery of electron, properties of cathode rays. First of all, recap of our previous lecture. Students, in our previous lectures, chapter number 1 was discussed with you, which was fundamentals of chemistry. In this chapter, we discussed different branches of chemistry, concept of element, symbol, valency, compound and mixture. We also discussed concept of mole and Avogadro's number. Now, objectives of our today lecture. Students, after today lecture, you will be able to explain discovery of electron. What is the experiment of this discovery? Properties of cathode rays. First of all, who was J.J. Thomson? Students, Sir Joseph John Thomson was born in 18 December 1856 and died in 30th August 1940. He was a British physicist. He was credited with the discovery of electron, the first subatomic particle to be discovered. Sir J.J. Thomson was awarded the 1906 Nobel Prize in Physics for the work on the electricity in gases. Now, what was the contribution of Sir J.J. Thomson? J.J. Thomson experiments with the cathode ray tube showed that all atoms contain tiny negatively charged subatomic particles known as electrons. Thomson proposed the plum pudding model of atom, according to which negatively charged particles embedded within a positively charged particle. The basis of this name of this model, plum pudding, related to a plum pudding dessert made on the time of Christmas in UK, Ireland and other countries. He related plum as an electron, pudding as a positively charged. So he said electrons, negatively charged particles embedded within a positively charged particles. Cathode rays and discovery of electron. In 1895, Sir William Crookes performed an experiment. Student, Sir William Crookes was a British chemist and physicist. He was pioneer of vacuum tubes. He worked on spectroscopy. He passed electric current through gases in discharge tube. During his experiment, pressure was kept very low, that is 10 raised power minus 4 atm. Two metallic electrodes were fitted in glass tubes. Metallic electrode was cathode and anode. Cathode is negatively charged while anode is positively charged. High voltage current was passed through gas. Shiny rays were produced through cathode. So these rays were named as cathode rays as they are originated from cathode. What is discharge tube? Students, a gas filled tube, also known as discharge tube, is an arrangement of electrodes in a gas within an insulating temperature resistant envelope. For example, glass. Students, look at this diagram. Students, in this diagram, a glass tube contains two electrodes, cathode and anode. In this glass tube, a gas is filled at very low pressure. So this glass tube is known as discharge tube. The voltage required to initiate and sustain discharge or to pass electricity is dependent on the pressure inside the glass tube, composition of gas filled in the glass tube, and geometry of the tube. If we want to define discharge tube, we define as a gas discharge tube is usually a glass tube with two electrodes sealed through its wall. When a high voltage is applied to the two electrodes and the pressure of the gas in the discharge tube is reduced, eventually a pressure is reached at which a current flow. Students, at ordinary pressure or atmospheric pressure, there is high resistance between two electrodes, so current did not flow. So it is necessary to reduce the pressure. Properties of cathode rays. Cathode rays travel in straight line perpendicular to the cathode surface. They cast shadow of an opaque object which is not transparent, which kept in their path. Look at this diagram. An opaque object is placed in the path of cathode rays. These cathode rays did not pass through it, so they cast shadow like light. In electric field, they deflect towards positive plate. Students, look at this animation. If we apply the electric field, the cathode rays bend towards positive plate. They raise body temperature on which they fall. Students, cathode rays when hit a body, they increase the kinetic energy of particles of that body, so temperature of that body increases. J.J. Thomson discovered their E over m value. E over m value means charge to mass ratio, which is 1.758820 multiplied by 10 raised to power 11 coulomb per kilogram. On the wall of discharge tube, they produce glow. Look at this picture, students. Cathode rays when hit the wall of glass, they produce glow. This glow do not depend on nature of gas, but in fact glow depend upon the nature of glass. The quality of cathode rays suggested that these are the fast moving material particles. Material particles mean they possess momentum, or we can say they have mass or velocity. Students, if we place a paddle wheel or small wheel in the path of cathode rays, these cathode rays when hit this paddle wheel transfer its momentum and this paddle wheel rotates. So we can say cathode rays possess momentum and these are material particles. Now, conclusion of this experiment. In 1897, British physicist J.J. Thomson showed that cathode rays were composed of previously unknown negatively charged particle, which was later named as electron. Students, whatever the gas is used during the experiments, nature of cathode rays remain same. So it suggested that cathode rays are basically electron. So electrons are the fundamental particles of an atom. Now recap of our today's lecture. Students, in our today's lecture we discussed history of J.J. Thomson, how cathode rays were discovered, properties of cathode rays, and conclusions of Sir William Crookes experiment.